I am Nur Ain Akasha will begin the presentation. The presence of sulfur dioxide in fruit juice is crucial for preserving the quality and extending the shelf life of the product. This study aimed to investigate the feasibility of utilizing UVB spectroscopy as a reliable technique for the quantitative analysis of sulfur dioxide in various fruit juice, and we choose in orange juice. In this experiment, we will prepare a series of sulfur dioxide solution of known concentration and determine their absorbance using UV visible spectrometer to determine lambda max of sulfur dioxide and to prepare the calibration curve of Beer's law plot. This information will be used to find the concentration of unknown solution, which is in orange juice, to determine the existence of sulfur dioxide. Next, we will discuss why we use sulfur dioxide in manufacturing juice. Alright, sulfur dioxide primarily used as a preservative and antioxidant, help preserve the freshness and quality of fruit juice by limiting the oxidation of natural components. It also prevents fruit from browning, retaining their beautiful color and flavor. Sulfur dioxide also acts as an antibacterial agent, effectively limiting the growth of undesirable bacteria and yeast. Its application extends juice shelf life and aids to overall longevity of the product. However, high quantity of sulfur dioxide can have a negative effect on the sensory quality of the juice, and it must properly regulated and monitored. Remember, everything we use in fruit juice or any fruit product have their own advantage and disadvantage. Okay, let's see what is advantage sulfur dioxide in manufacturing juice. Is a major function as a preservative, extend the shelf life of fruit juice by suppressing the growth of spoilage bacteria. It also improves product stability and extending shelf life. Furthermore, sulfur dioxide is an effective antioxidant that protects the visual appeal, flavor, and nutritional value of juice by avoiding enzymatic browning processes. Sulfur dioxide antibacterial capability help to preserve microbiological safety throughout manufacturing and storage. It also ensures that the finished product fulfill quality requirement. Alright, let's jump to disadvantage. What is become disadvantage to us? It is because we overly use or we put so much sulfur dioxide in fruit product. Okay, it will cause an allergic reaction or a worry for sensitive people, necessitating with precise labeling. Excessive usage may also affect the flavor profile, resulting in unwanted sensory quality, and there are legal limits to manage in terms of acceptable amount to protect consumer safety as well as environmental responsibility.
Next, for literature review about this project, we know that sulfur dioxide, which is SO2, had been widely used in the food production. It is very beneficial for various types of food. In this experiment, we want to determine the existing of sulfur dioxide SO2 in the production of orange juice sample. Based on previous study, some experiments were conducted in order to determine the existing of sulfur dioxide SO2 in the production of wine. The result shows that sulfur dioxide can be detected at the wavelength of 532 nm and also with the value of R square 0.997 and 0.9983. The other studies shows that sulfur dioxide SO2 can be identified in the production of beer with a wavelength of 340 nm. It shows that R-square value achieved 0.997. In this way, it can be proved that sulfur dioxide is directly proportional to the content in the sample. Based on the previous studies, our result shows that wavelength of 340 nm can identify the existence of sulfur dioxide, which can relate that our R-square value is 0.9.
Assalamualaikum and hi, I'm Nur Izzati Khadijah. Today I will present to you about method involved in this project. First of all, UV spectroscopy is a quantitative technique used to measure how much a chemical substance absorbs light at the ultraviolet wavelength range of 200 to 400 nanometer to the visible wavelength range of 400 to 700 nanometer. This is done by measuring the intensity of light that passes through a sample with respect to the intensity of light through a reference sample or blank. This property is influenced by the sample composition, potentially providing information on what is the sample and at what concentration. As we know, UV spectroscopy has been applied in numerous ways to facilitate qualitative and quantitative analysis as well as structure determination and online reaction monitoring in a wide range of environments. Besides, UV is used to obtain the absorbance spectra of a compound in solution or as a solid. What is actually being observed spectroscopically is the absorbance of light energy or electromagnetic radiation, which excites electron from the ground state to the first single excited state of the compound or material. Next, I will explain about details about UV spectroscopy. A spectrophotometer is a scientific instrument used to separate and measure spectral components of a physical phenomenon. A UV spectrophotometer measures the light absorption of a substance in a cuvette, determines its concentration, purify, and physical properties. For your information, spectrophotometer is a broad term often used to describe instruments that measure a continuous variable of a phenomenon where the spectral components are somehow mixed. In visible light, a spectrophotometer can separate white light and measure individual narrow bands of color called a spectrum. A mass spectrophotometer measures the spectrum of the masses of the atom or molecules present in a gas. The first spectrophotometer were used to split light into an array of separate colors. Lastly, the capability of spectroscopy to determine chemical composition drove its advancement and continues to be one of its primary use. So this is our procedure for part 1 which is preparing the N2SO3 stock solutions. And then for part 2, preparing the N2SO3 working solutions. So next we go to the part A, which is obtaining an absorbance spectrum to determine lambda maximum. So next for part B is preparation of a concentration curve or Beer's law plot. And then for the last part is determining the concentration of unknown solution. So this is our table and our dilution factor diagram.
I am presentation of the class, so I will present about the result. This table is divided into the concentration and absorption. So the total concentration is divided into 5, which are 0.0625, 0.0125, 0.025, 0.05, and 0.1. So for 0.0125 and 0.05 are unknown because the form a Boolean graph and the value R is a 0.99. So the first concentration is a 0.001 0.625 and absorbance 0.17855. Then second concentration is a 0.0025 and absorbent 0.18363, and the final concentration is a zero point 0.1 and absorbent is a 0.23117. And then the graph of absorbent is a y-axis and versus concentration x-axis can be prepared. So the graph will produce a straight line plot. So the calibration curve is a prepared. So we need to determine the concentration of an ion sample by measure its absorbent. So the measure absorbent is located on the graph. So a horizontal line is a draw from the absorbent to the calibration curve. So vertical line is a down from the curve to the concentration. So this will indicate the concentration of final sample. So the equation is y equal to mx plus c. So y is equal to absorbent, s is equal to concentration. So the equation is y equal to 0.5783x plus 0.1735. So the value absorbent is y equal to 2.1979. So the next step to know the concentration juice. So the concentration juice equal to 2.1979 minus 0.1735 divided 0.5783. So the total concentration is a 3.50. Finally, the UV-Vis calibration curve show a strong linear relationship between absorption and the concentration of a sodium sulfide. So the slope of the curve can be used to calculate the molar absorbent, which provide a accurate approach for evaluating the concentration in the future investigation. So according to the journal, the sulfur dioxide at the maximum reference 340 peak and distillate is correct. So the correlation coefficient value of a 0.9971 suggest a modern fit with the beer lambat law, and the accuracy of our project is available. So to determine the concentration of the fruit juice, so we know that the concentration of fruit juice is 3.50 by absorbent at 340, which is a 2.1979 based on experiment.
So I will present the recommendation for future work. First of all, regular calibration using standard reference materials is essential for maintaining accuracy while consistent maintenance schedule, including the cleaning of optical component and verification of alignments, prevents instrument drift and ensures longevity. Besides that, predict shifts of the spectrophotometer's wavelength. Settings are necessary to confirm accurate readings across the specified range. Other than that, the establishment and adherence to quality control standards for sample preparation and analysis are critical for maintaining consistency and reproducibility. Lastly, standardized operating procedures should be developed and followed meticulously. So thank you, that's all from me.
Hence, UV spectroscopy at specific wavelength, which is 340 nm, is a reliable and efficient method for determining the concentration of sulfur dioxide (SO2) in orange juice. Sulfur dioxide (SO2) absorbs light at this wavelength, and degree of absorption is proportional to concentration of SO2 in sample. The calibration curve generated by measuring standard solution with known SO2 concentrations enable the measurements of SO2 level in orange juice sample. Thus, a highest peak of absorbance of 340 nm shows the existence of sulfur dioxide can be identified with the concentration of 3.50 mole. The method and accuracy are determined by the calibration curves, quality, and sensitivity of UV-Vis spectrophotometer utilized.